Watch this. 9 out of 10 students, literally 90%, get binary conversion and core computer science concepts wrong in exactly the same way. And the worst part? It quietly costs them the grade. They might actually understand how a system works in their head, but when it's time to put pen to paper, they fall right into the trap of using everyday language instead of technical precision. Well, in this explainer, we're going to fix that. Let me show you this mistake before you make it. So, take a look at the left side here. This is the classic trap. It's kind of this messy web of guesswork that dances around the idea, but totally lacks any real structural logic. Now, look on the right. Here, we see the precise mechanism for binary conversion. We aren't just magically stating the final number. We're logically mapping out the base 2 values, step by step. And honestly, once you see the discipline of this correct flow, it becomes absolutely impossible to forget. So this brings up the golden question, right? How do we transform that basic, everyday understanding of a concept into the exact technical wording the examiners are actively looking for? Well, the secret isn't just memorizing more facts. It's really about understanding the layered frameworks behind the technology and then strictly applying them to whatever specific scenarios you're given.
All right, let's jump right into Section 1, the path to connection, modems versus routers.
Okay, so network hardware is a massive tripping point for a lot of students. I want you to think of the modem strictly as a signal converter. It's that absolutely crucial piece of hardware bridging the gap between the analog infrastructure of the phone lines and the digital environment of your computer. So, when you write about a modem in an exam, you can't just say it gives you internet. No way. You've got to describe it as modulating and demodulating signals to facilitate that connection to your internet service provider's infrastructure. Now, the router, that's a completely different beast. You can think of it kind of like the strict bouncer and director of the internet. While a modem translates the signal, the router acts as the gateway connecting your local area network, your LAN, to the wider internet. Its main job is to efficiently route data packets to specific, intended receiving devices. It's what allows multiple devices on your home network to share that single internet connection at the exact same time. Trust me, confusing these two distinct pieces of hardware is a guaranteed way to drop easy marks. To avoid that vague trap we talked about earlier, you've got to explicitly apply your definitions to a specific scenario. You need to explain the how and the why. Don't just spit out a definition of a router. Explain how it connects, say, the office network provided in the question to the internet and why it's necessary for those specific workers to communicate. Always focus on those command words, describe what it is, and then explain its function strictly in context. Let's move on to our next concept and see how this all builds, because confusing the World Wide Web with the underlying internet is another absolute classic trap. Just remember, the internet is the massive global physical infrastructure, literally the interconnected network of networks. The World Wide Web, on the other hand, is the collection of multimedia web pages, software, and protocols that are actually running on top of that infrastructure. To truly master web technologies, you need to progress through 3 distinct layers of understanding. Layer 1 is just your simple, everyday explanation, basically grasping the fundamental purpose of a web browser. Then Layer 2 is where you transition into using proper technical vocabulary, describing those mechanisms accurately. And finally, Layer 3. This is the ultimate goal. This is where you shape that technical knowledge into a concise, timed exam response that directly hits specific mark scheme requirements. Whether you're explaining how a browser renders HTML or maybe why a bank uses HTTPS, the discipline remains exactly the same. You have to order the sequence logically, and crucially, you have to anchor it in a specific context. The examiner doesn't just want to know that HTTPS encrypts data, they want to know that it specifically secures customer payment details for the exact online retail store mentioned in your prompt. So to secure those higher marks on demanding questions, always follow these 3 steps in this exact order. First, clearly explain the core mechanism of the technology. Like, how does it physically or logically work? Second, state the consequence or advantage of that mechanism. And third, apply it directly to the scenario application. Never, ever start with the advantage before you've proven you actually understand the core mechanism. Okay, moving right along to Section 2, perfecting checksums and data integrity. Let's think about a totally everyday problem. Imagine a broken product barcode at a supermarket checkout. We intuitively know why that's a problem, right? But to succeed in the exam, we have to translate that broken barcode scenario into precise technical vocabulary. We need to use terms like error detection algorithms, checksums, and data validation.
Now, a high-scoring exam strategy requires you to separate your description of a checksum from your explanation of how it actually works. You have to clearly state that a checksum is calculated from the data before transmission, then recalculated upon receipt. And finally, those two values are compared to detect any errors during transmission. It acts almost like a digital receipt for your data. And getting this mechanism ordered logically, that is non-negotiable. It's quite literally the difference between getting a top grade and having to start over.
Let's just pause here for a second to highlight these exact traps, because these are by far the most common ways students lose marks. Number one, vague wording. Using phrases like, it checks the data, instead of saying it compares the calculated checksums. Number two, missing steps in the sequence, like jumping straight from calculation to error detection without even mentioning the comparison phase. And number three, generic, unanchored responses. If the question asks about data integrity in a banking network, your answer absolutely must reference the banking network, not just say the data. Shifting gears into hardware, let's ask ourselves a really foundational question. What exactly separates an embedded system from the laptop or phone you're using right now to watch this? This distinction is absolutely critical for Paper 1. Whether we're analyzing a smart thermostat setting the room temperature or maybe a digital toothbrush tracking your brushing habits, these are embedded systems. But why? Well, because they are purpose-built for a single, dedicated function within a larger mechanical or electrical system. You have to transition from identifying this everyday problem to using formal computer science terminology. An embedded system is not a general-purpose computer. It uses a microcontroller to execute specific, pre-programmed tasks. And you have to ground your answers in the provided context. Context specificity means keeping your technical explanation strictly tied to the provided scenario. That way you don't lose marks on generic facts. For example, if the exam asks about an embedded system in an automated greenhouse, you need to talk about sensors detecting soil moisture and microprocessors triggering irrigation. Don't just write down generic stuff like input and output. All right, let's bring it all home with Section 3, the ultimate exam strategy, the 3-pass cycle. To tie everything we've talked about together, we use the 3-pass revision cycle. This is literally your definitive blueprint for success. Pass 1 is all about securing your foundational definitions and contrasting closely related terms, like knowing the exact difference between a router and a modem, like we discussed. Pass 2 is practicing rehearsed structures. That means literally writing out the logical sequence of an HTTPS handshake or a checksum calculation. And Pass 3, that's scenario adaptability. That's taking that rehearsed structure and twisting it to perfectly fit whatever unique, crazy scenario the examiner throws at you. So before you finish any exam question, I want you to run your written answer through this strict 4-question diagnostic check. Ask yourself, did I clearly define what it is? Did I logically explain how it works step by step? Did I explicitly state where it's used in relation to the prompt? And did I justify why it's used over an alternative? If you can confidently answer yes to all 4 of those, boom, you've engineered an airtight full-mark response. Making that leap from an average grade to top marks isn't really about working harder. It's about working smarter and understanding exactly how to communicate your knowledge. So, if this structured, visual explainer approach made the concepts click for you, be sure to subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCE to excel in your Cambridge examinations. We've built the framework and we've analyzed the traps. But remember, computer science isn't just about memorizing facts about hardware. It's about understanding the invisible digital infrastructure that runs our entire world. So, which piece of that complex, invisible world should we deconstruct next? Let me know, and keep applying these layered strategies to your revision.